we say that's before the cosmic microwave background radiation, we have limited access or no access to that era. Like some debates, maybe you know them better than me. But do you think the gravitational waves can contribute to that, or it's out of our reach?
Well, the gravitational waves are extremely penetrating. When we first saw a gravitational wave in 2015, the observational data told us that the gravitational wave came up from the south. It entered the Earth in Antarctica, traveled through the Earth, and emerged at our gravity wave detectors coming upward from inside the Earth. And we saw them. So it wasn't coming down from the skies, it was coming up from below. And the waves were unaffected by all the matter of the Earth. Similarly, you can make reliable estimates of how penetrating they were in the very early universe. And the bottom line answer is that there was a negligible amount of absorption of gravitational waves or scattering of gravitational waves from the very beginning of the universe until today. And that's incredible. They are the most penetrating form of radiation that known to us. And that means that whatever kinds of gravitational waves were created in the birth of the universe, and quite likely amplified in strength by the process of inflation that we think very likely occurred in the early universe, a very rapid initial expansion. Whatever came off of that, the birth of the universe, and then amplified by inflation, we should be able to see. And there are tentative plans for instruments that will see that. Well, there actually are instruments that are looking at the present time, but looking for primordial waves. This is not LIGO. It's not the kind of gravity wave detector I've worked on, but rather those primordial gravitational waves are thought to have interacted with the hot plasma of the early universe at the time the plasma was recombining, so that it was becoming neutral, and are thought to have placed, and that's when the cosmic microwave background was released, last interacted with matter, and the gravitational waves are thought to have put a polarization, a very particular polarization pattern on the cosmic microwave background. That pattern's being searched for. It has been seen, but there's noise in the data, and that data have to be understood and the noise removed. But I think that will be successfully done in this decade. So by about 2030, we may well then have an instant observation of the primordial gravitational waves through the imprint that they put on the cosmic microwave background. So that's fabulous. But even more interesting is in the 2050 time frame, there's likely to be a space mission, a follow-on mission to the planned LISA gravity wave mission, a second generation gravity wave mission, currently called the Big Bang Observer, which can directly see the gravitational waves at periods of a few seconds. Very, very different period than the periods of the waves that you see through the cosmic microwave background. And so I think it's quite likely that we will see, by the middle of this century, we will see the gravitational waves in these two different frequency bands. One very, very long periods, that is the polarization pattern, and the other very short periods. And we will be using them to try to decipher what was happening in the Big Bang in the earliest moments of the universe. So that, for me, is sort of the holy grail of this field for the period, for the epoch of the middle of this century.
That's great. I'm too happy to hear it. That's something we want to see it for sure. Understanding our early universe, how the universe evolved, how we came to this where we are right now. That's a lot of question to answer. Gravitational waves is the one to do it for sure. I remember when the first discovery just was released, when I sit and talk to people that's doing quantum gravity or gravitational physics, the main thing was saying we are entering a new era of cosmology. Everything will be different from now on. So we're looking for it.